Okay. Alright, hey there everybody. My name is Wilfred and I'm a senior math tutor. And today I'll be covering 10 questions related to calculus, related to derivatives and integrals. A little bit backstory upon myself. I graduated from McMaster with a major in biochemistry and a minor in mathematics. And yeah, if you have any other issues with your homework or tests or assignments, please submit them through OneClass and we'll get to them as soon as possible. So let's jump right into it. Okay, so the first question reads, how do you calculate the left and right Riemann sum for the given function over the interval 1, 5 using n equals 4 for f of x equals 3x? Okay, so first of all, let's try to graph this function first and see what it looks like. So we see here that this function is a line function with slope of 3 and y-intercept of 0. Let me just make this a lot larger. Okay, cool. Alright, so let me just label our axis here. Let's draw this line. So it's kind of steep, so we'll just draw it like this. Alright, we'll draw it like this and we'll label 1 to be here. So this, no. So yeah, so these units aren't going to be exactly in scale, but we're going to have 1 here, we're going to have 5, which is going to be like here. 5 and 5 is going to be like up here somewhere. Maybe 5 is too far. We'll put 5 to be here. And that will be like around here, so this is going to be 15. Okay, so the x and y axis are not on the same scale, as you can see here. Obviously not, but we'll make do. So the left and right Riemann sum is a method of calculating the area under the curve. It basically approximates the areas by adding together rectangles underneath or above the curve, and I'll explain how. Okay, so the other pieces of information that they gave us is we'll be calculating the Riemann sum over the interval 1 and 5 using n of equal 4. So we're going to be calculating 4 different rectangles, the areas of those rectangles, and then we're going to be adding them all together. So first of all, we need to calculate how many rectangles, or how many, I guess, the width of each rectangles are, and how we're going to calculate it is through this equation here. So the equation for the number of the width of each of the rectangles is going to be delta x. So delta x is going to be the width of each of our rectangles, and they're all going to be the same, and they're calculated by b minus a of the interval divided by the amount of rectangles that we have. So here the interval is 5 and 1, so we're going to do 5 minus 1 divided by 4. And we get 1. So the width of each of our rectangles is going to be 1. Okay, so now that we've gotten that out of the way, I want to just explain what a Riemann sum looks like. Okay, so we're going to have 4 rectangles, each with a width of 1. So the first rectangle is going to be from 1 to 2, from 2 to 3, and from 3 to 4, and from 4 to 5. So there's going to be 1 rectangle here, second, third, and fourth. Okay, so if we were to approximate this rectangle, so this first rectangle from 1 and 2, there are 2 different rectangles based on the length of the rectangle itself. So as you can see here, between this interval, we can either take the length of 3 or we can take the length of 6, right? So if we were to do this, let me draw this in a better way. Okay, so let's use green. So we can either use a length of 3 and a width of 1 and calculate the area of this rectangle, or we can calculate the length of the rectangle using the other height, which is from the other end of the interval, which is 2. So we can use the length of 6 and the width of 1 for this rectangle. So there's 2 ways to calculate these rectangles. Okay, and this is where we differentiate between the left and right Riemann sum. The left Riemann sum uses the leftmost value of for the length of the rectangle. So in this case, we'll be using the green. for our left Riemann sum, while the right Riemann sum will be using the right value for the length of a rectangle, which in this case is 6, right? So let's put 6 here, right? I'll draw the other rectangles for you using the left Riemann sum. So if we were to use the left Riemann sum, we'll calculate this rectangle. And sorry about my drawing here; it's pretty bad. Okay, so we'll be calculating if we were using the left Riemann sum, we'll be calculating the areas of each of these rectangles using the left value, right? So the left value is the left interval of each of the rectangles. Okay, if we were to use the right Riemann sum, then we would also have to add on. We'll have to use the right value, so we'll be using the green plus the orange rectangle, right? Okay, so that's how we calculate the left and right Riemann sum. So we calculate each of these areas, and the areas of these rectangles are length times width, right? We know what the width is 1, and we know what the length is, right? So that's how you calculate each of the left and right Riemann sums. So let's calculate the left Riemann sum first, okay? So one more thing that I need to describe is the equation for the Riemann sum. Okay, so the equation for a Riemann sum is the sum. So this is the notation for sum between 4 and r equal 1. Here I put x equals 1. I don't know why it's 4. Of f of x times our width, right? So this is how you calculate the Riemann sum, and I'll use the notation rs to denote that. Okay, so this is the notation for left and right, but it changes based on whether we're using left or right. So if we're using the right, we're using 6, we're using 9, we're using 12, and we're using 15, right? So let's calculate our left Riemann sum first. So the notation for left Riemann sum is going to be this. So with this notation, we could take the constant of the width out, and we just need to add up all the values of the left Riemann sum. Right, so from 4 to okay, x equals 1, so that will be equal to f of x. Okay, so the junior tutor kindly provided us a solution for this. So it's delta x times f of 1, which is 3, f of 2, which is 6, f of 3, which is 9, and f of 4, which is 12. Okay, so here these correspond to 1, 2, 3, and 4, which is our left values for our Riemann sum. Right, and if we add all of this together, this is 1, this is 9, 18, 30. Okay, let's calculate our right Riemann sum now. Okay, so delta x. Here we're going to exclude our 1 value here, so we're going to calculate from 2, x equals 2, to 5. Okay, of f of x. And if we do so, we'll get delta x, our 1, times f of 2, which is 6, f of 3, which is 9, f of 12, f of 4, which is 12, and f of 5, which is 15. And if we add this all together, we get 15 plus 12 is 27, 27 plus 15 is 42. Okay? Alright, so that's how you calculate left and right Riemann sum. So let's look at this geometrically, for example, right? So for our left Riemann sum, it actually it has an underrepresentation of the area because we are missing this whole area from the rectangle base to the actual function. While on the right Riemann sum, we're over approximating the area because we have a bit of the rectangle of the area that is not included or under the function itself, right? So you can see here that that corresponds to our left and right Riemann sum. Our right Riemann sum is 42 and our left Riemann sum is 30. If we were to actually calculate the area under the curve, which is just our integral here, we would find that the curve is actually equivalent to 36. So let's calculate the area, and then I'll explain to you how the left and right Riemann sum work in relation to the integral itself. Okay, so the area is the definite integral of our function from 5 to 1 in terms of dx. Okay. So if we were to differentiate this, we would get 3 of x squared divided by 2 of 5 and 1. And that gives us 3 over 2 of 25 minus 1. And if we were to simplify this, we would get 36. Okay, so we can see here that the area under the curve is in between our right and left Riemann sum. So how does this all relate together? So actually, the integral can be derived from the right and left Riemann sum. And the way that is derived is that the integral actually calculates the addition of very, very small rectangles with very small width altogether. So as the width approximates and gets closer to 0, we get closer to the actual area under the curve. So if, for example, we were to say, oh, we want more rectangles, so let's say we wanted 20 rectangles within our interval. If we have 20 intervals within our rectangle, our left and right Riemann sum will get closer and closer together, and they'll be heading towards the actual area under the curve. And that's how an integral is calculated. It calculates the sum of very thin rectangles, so numerous rectangles within the interval, and by doing so it can approximate the area under the curve to a very good degree. So that's how an integral works, and it's based off the left and right Riemann sums, which are ways of trying to approximate the area under the curve. Okay, so other than that, this answer is correct, and this is how you calculate the left and right Riemann sum. For the left one, you want to use the leftmost intervals for each of the rectangles, and for the right Riemann sum, you want to use the values for the rightmost interval for each of the rectangles. And to calculate the width of the rectangles, you have to determine how many rectangles you have, and you need to calculate how many rectangles, or the width of those rectangles within the interval. Okay, so this solution is correct. Good work. Okay, cool.